is warming. Since the pre-industrial time, our Earth's average temperature has risen by 0.8 degrees Celsius, and it is projected to rise another 1 to 6 degrees over the next 100 years. As of now, many places have seen changes in rainfall, resulting in more floods, intense rain, or drought, as well as more frequent and severe heat waves. Oceans are warming and becoming more acidic, and coral are bleaching. Ice caps are melting and sea levels are rising. Disease factors are changing their distribution, and people died as a result of extreme weather. When the temperature rises by 2 degrees Celsius, our food security will then be severely impacted. More children will be killed by famine, and the food price will increase globally. Coastal flooding will be much more frequent, and millions of people will be affected each year. By the time we hit 3 degrees Celsius increment, our ecosystem will be strongly affected. 30% of global wetlands will disappear, and the impacts it brings on public health will impair our health system substantially. Most importantly, this will probably be a point of no return, where the effects of climate change will simply overwhelm us. As such, the increment of temperature should be kept well within 2 degrees Celsius by the end of the century. This would not simply save us from all the catastrophic effects of global warming, but it also leaves room for the development of our future generations. To achieve the goal, our carbon dioxide emission on average will need to be lowered from 3 ppm per annum to around 1.5 ppm per annum, down by 51%, all the way to the end of this century. Undoubtedly, this is not achievable overnight. This is achievable in a progressive manner just by lowering down our emission by 1.5% every year. To further understand how can we achieve a lower emission, it is important for us to take a look at a simple equation that relates the carbon dioxide emissions with human activity. This equation is known as Kaya identity, developed in 1993 by Japanese energy economist Yoshikaya. On the left side is the amount of carbon dioxide emissions, while on the right hand side is simply the carbon dioxide emission, energy used, GDP produced, and population. Each implies energy carbon intensity, energy utilization rate, GDP per capita, and population. As the economic growth and population increase, the increment in the first two terms will result in increase in carbon dioxide emissions, whereas when the technology improves, energy will be utilized more efficiently and lead to a decrease in the third term. Nonetheless, the decrement relies on technological improvement is unlikely to have any sharp decrease within a short period of time. The last term, the amount of carbon dioxide released per unit of energy produced depends largely on the source of energy.
As of now, fossil fuel makes up roughly 67.4% of the world energy production. To reduce the carbon intensity of energy, there are many pre-existing green technologies, such as nuclear reactors, hydroelectric plants, solar cells, biofuels, and the list goes on. Among these energy sources, fossil fuel has the highest carbon dioxide emission intensity. In comparison, all other energy sources have much lower carbon dioxide emission intensity. However, these green energy sources cannot meet our needs sufficiently. Winds don't blow all the time. Hydroelectricity and geothermal doesn't work everywhere. Therefore, today, we would like to make a bold proposition, one that you are familiar with yet foreign to. We propose that to significantly reduce carbon intensity of energy, we should focus on developing nuclear energy in order to greatly reduce our reliance on fossil fuels for generation of electricity. By increasing the nuclear energy production at around 2% per year, it is entirely possible to keep achieving a 1.5% decrement in carbon dioxide emission annually. As a result, the increase in carbon dioxide concentration will be lowered and our temperature increase will be kept at around 2 degrees Celsius. Nuclear power, in general public perception, is dangerous and unreliable. But in fact, it is exaggerated by nuclear accidents and nuclear weapons. Today, we are introducing to you a new hope for our future, an extremely safe and efficient kind of nuclear power, thorium.
Thorium is a naturally occurring radioactive chemical element, and it can be used to generate nuclear energy. It generates a very low amount of carbon dioxide relative to its energy output. In a thorium fuel cycle, thorium-232 absorbs a neutron and yields uranium-233. The following nuclear fission reaction produces large amount of heat. On the surface, uranium and thorium may seem similar, but thorium fuel cycle has many advantages over uranium fuel cycle. First of all, thorium is highly abundant. In fact, thorium is 4 times more abundant than uranium, 3 times more abundant than tin, and as common as lead. This makes it a potentially cheap nuclear energy fuel. On top of that, it is the most energy-dense material on Earth. Comparing the amount of thorium needed with coal, it is estimated that 1 ton of thorium can produce as much energy as 200 tons of uranium or 3.5 million tons of coal. Furthermore, thorium-based nuclear technology is definitely a key skill. Unlike uranium, weapon-grade byproduct of thorium is highly contaminated with unwanted isotopes, making it nearly impossible to be utilized for weapon development. In addition, the thorium fuel cycle is efficient. Up to 98% of thorium used in a thorium reactor can be burned. In contrast, only 0.6% of uranium involved in the uranium fuel cycle is burned. As a direct result, nuclear waste production is much less than that of uranium. Some researchers even claim that it generates 1,000 times less waste than uranium. A conventional uranium-based nuclear reactor makes use of spontaneous nuclear reaction to generate heat and electricity. To keep the reaction under control, layers after layers of water cooling systems and backup electricity generators are needed to ensure the reactors are cooled down all the time. Remember the Fukushima nuclear disaster? It was a series of equipment failures, nuclear meltdowns and releases of radioactive materials. Whereas using thorium-based reactor, you will need to constantly heat up the reactor to molten state to get the reaction running. Under normal conditions, the reactor has a small plug down at the bottom of the reactor vessel. There's a piece of frozen salt that is being kept frozen by constantly blowing cold wind onto it. In case of an emergency, the supply of cold wind stops and the plugs melt. Since the thorium reactors using molten reactant, this liquid reactant will get drained into drain tank. The drain tank will dissipate heat, cooling the reactant which will freeze and stop reacting. Most importantly, the thorium-based reactor does not use a water cooling system and therefore holds no risk of heating and pressurizing water coolant. As such, hydrogen or pressure explosion is impossible.
Now that we have talked about thorium-based nuclear energy, you might be wondering, what is in it for you? By turning to green energy sources, you not only aid in creating a less polluted environment, your country can achieve many other amazing benefits. Similar to the kaya identity, we can relate a country's GDP with energy consumption and resources in another simple equation. All we need is to put GDP on both sides of the equal sign, followed by energy consumption and resource. In this equation, the first term is equivalent to the energy utilization efficiency. The second term represents the energy cost, and the last term is simply the amount of resource you have to provide. With potentially cheap energy sources such as thorium, the amount of energy produced per unit resource can be increased substantially. As a result, the same amount of resources can now yield an incredible amount of GDP growth as compared to using the expensive fossil fuel-based energy. In our world now, the price of fossil fuels is heavily manipulated due to its high demand. Hence, the cost of fossil fuels tend to increase annually. By turning to alternatives, it can be less reliant on fossil fuels, and therefore more resources can be used for other income-generating industries. This increases economic stability and GDP growth. Currently, most green energy sources are still under research to increase the effective use and improve energy efficiencies. Once the technologies have been developed, many benefits can be obtained. This makes investments into these green energy sources very viable and lucrative. We should provide funding and incentives for the setup and management of the R&D companies and power plants to attract more people to develop these facilities. Moreover, countries should cooperate to ensure free trade and a free market for the energy sources such that even developing countries can afford to invest and benefit from these green technologies. This will allow the world to progress economically and still have a cleaner atmosphere. Our abatement strategies rely on the reduction of CO2 emissions generated in the course of energy production by using alternative energy sources. Investing in these technologies provides countries with multiple benefits, including more self-reliance for energy, economic stability, and economic growth. Green energies can prevent the apocalyptic future brought forth by global warming. Now is the time to start investing for a green future for everyone.